Alright, so question 20 asks you, do spherical proteins tend to sediment slower or faster than rod-shaped proteins with identical masses? Well, the equation for sedimentation is given to you right here. So S is equal to m, which is the molecular weight of the protein, times this quantity 1 minus v bar rho over n times F. Alright, and we talked through what all these different components are here. Well, the component that we're really interested in for this problem is the frictional coefficient right down here, F. Alright, so because shape determines the amount of friction that that protein is going to experience as it's moving through the centrifuge tube. Now, proteins that are more elongated, as you might imagine, they're going to have more surface area to be able to interact with liquid. And so because of this, elongated proteins tend to have greater friction, whereas spherical proteins, all right, they have less surface to be able to interact with other molecules, and as a result, the frictional coefficient of a sphere is minimal, right, compared to all other shapes. And so, the question is asking us, do spherical proteins, will they tend to sediment faster or slower than rod-shaped proteins? Well, a spherical protein has a low F value, which means that we have a low value in the denominator here. If the denominator is small, that tends to increase S. It'll increase the overall value by having a small denominator. So the answer to this problem is that spherical proteins will tend to sediment faster than rod-shaped proteins.